All right, it looks like we're live. Thanks everyone for tuning in, and let me know if you can't hear me, of course, as always, the way these things go with streams, but it looks like all my levels are good here. So I'm just going to go ahead and give us a quick review of what this project is and what the point of it is. Now, a lot of people want to ask what the point of the project is. The main point is really just that I feel like playing with some I2C devices on a Raspberry Pi. Why am I doing my development on the Raspberry Pi instead of doing it on, say, VS Code or something? Basically because I don't want to do it with VS Code. I like doing development on the Pi because I think that's fun. Now, I am going to be just, well, playing with some stuff today. Now, for a review of what we've got, we're going to go ahead and do this I2C dump here. Sorry, I2C detect. And we've got 4 different devices. 3C should be our OLED interface here, which we have just proven that we can turn on. That's all we've done so far. 69 is going to be our 9-axis position sensor here. And I guess if someone could send a chat in the message here and let me know that you actually can hear me and see everything that's going on, that would be awesome. All right, cool. Thanks. And then I've got, so this is device 69 because I have its AD0 line here, hardwired to hot, to positive power here. Excuse me, got something in my throat. And I've got device 68 is the real-time clock, and device 50 is an EEPROM that is also on this chip. I have not yet put a battery cell in my real-time clock. Let's see, what else do we have? On the right side, actually this is going to be the left side on your view, I have this flipped upside down so that the orientation of these components makes more sense for you. On the left side here, I've got my I2C bus, and I've got these 2 pins pulling off of here onto here. I do like this little project board. It is pretty handy. It came with the breadboard, and it came with this blue deal that has mounting holes for Raspberry Pis. And then over here on your right side, I have my power bus. And well, that's basically the gist of it at the moment. Now, I'm just trying to get myself talking to these devices, and I imagine at least some of you have been here for the earlier ones. Now, I am using NeoVim. I am developing on the Pi because that's what I want to do, because I think it's fun. And so I've been trying to abstract away some of the stuff, and we're going in some realm of C++ 20-ish, although the version of GCC that I have on here is like GCC 8.3. So we don't have a whole lot of C++ 20 features, but we have some, and we're trying to use some of them. Now, my actual... this still has some cruft in here, but I've got some utilities for read block, read byte, write byte, send command. I'm using, generally speaking, the SM bus interface from the kernel here. So if you want to follow along at all, go to the video description, and you will see that I have links to all the devices that I am programming. So the DS1307 is the real-time clock. It's the thing we've spent the most time with so far. And the actual project so far here is at lefticus/I2C_hacking. And I've got, let's see, my M24C32 is the EEPROM. We're not yet talking to this at all. And I think that's approximately where we are at the moment. Okay, so where I last left off, and this, I made a couple of notes actually after the last stream for things that I wanted to clean up, because I've been hacking, and I've been saying none of this is best practices behavior, but I'm trying to figure out where I can start to apply some C++ best practices and try to make this all better. So let's see, where are my notes? All right. The first thing is this I2C device here. Now, it has its own internal buffer that I am reading from and writing to. And at the moment, we have a race condition, and this is really bothering me because when I go to read the time, I read 1 byte at a time. Now, according to the documents for the DS1307 real-time clock device, when I send a start bit over the I2C bus, then it is going to set its own, this is the RTC, it's going to set its own internal buffer where it's going to copy the current time into that. And as long as I read bytes back out without sending another start bit, it's supposed to, or no, without sending another start bit, it's supposed to keep the same buffer. Now, I tried to use a normal read block kind of command for SMBus, and the device did not like that at all. It was just giving me back an error when I tried to do this. So that was not going to end up being a good idea for this device. So I'm just reading the bytes as fast as I can out here, and that does bother me because I still think there's a race condition where it's possible, like in an absolute worst case scenario, it could be an entire year date wrong. If I happened to read the data right at the exact moment that it was switching on December 31st at midnight to January 1st or something like that. And I don't want to, at the moment, go to the level of trying to do direct I2C programming. I want to try to use these higher level interfaces, and I've thought about this a lot, and I thought, well, one thing I could do is detect a race condition. I could just try reading the buffer twice, and if I successfully read the buffer twice, then it's the same data each time, then I didn't have a race. And if it's different data the second time, then I know that I need to read it a third time. And I also know that these transactions will take far less than a second because I'm able to read at least 400 kilohertz. And so that just doesn't seem like an ideal solution, but it seems like a possibility. But I want to kind of abstract this a little bit. So I want to have some sort of a read block thing. Now, right now, this read block is calling my I2C read block helper, which, according to the I2C SMBus read block data man page, this thing is going to read up to 32 bytes of data. And so I need an appropriately sized buffer, and I'm just returning this entire buffer. I'm thinking about more like a read with iterators. So I can pass in a begin and an end iterator, and it'll keep reading until it fills that buffer, or up to the max allowed by the device. Now, it turns out that most of these devices have a slave transmitter mode. The first byte is received and handled as in the slave receiver mode. However, in this mode, the direction bit, so this is where I say that we're reading the slave, blah, 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 blah. All right. If the register pointer is not written to before the initiation of a read mode, the first address that is read is the last one stored in the register pointer. So it's going to keep reading. It has its own internal register pointer. The register pointer automatically increments after each byte are read. Each byte is read, something like that. All right. Hey, Leslie. Relatively small crowd today. So definitely see your messages pop up at the moment. And I'm hacking on this, like I said, completely unannounced, just because I felt like doing this. I want to get past this problem here. So what I want is I'm going to make my own auto increment read that takes a set of iterators and reads into that data, just calling read. That's this one right here, smbus read byte, which does not send an address first. And I'm going to read a block using that. That's my plan. Trying to decide, I don't know, should I use different types for begin and end iterator? That's allowed in a lot of cases now, but not in standard algorithms so much. I'll just go with iter at the moment. So I have to do the first read that sets up the address, and then I have to do a bunch of subsequent reads that just let it auto increment. And this is definitely something that'll be reused later for other parts of this library also. I find this kind of frustrating because I have to do, first I have to do a read and put that in the first byte. And then, I have to do a read byte data, this one right here, where I pass in the address and read. And then I have to do a bunch of subsequent read bytes. So the very first one has to, I mean, if I'm past an empty buffer, how do I deal with that? So if I've got begin, and buffer end equal the same thing, I'm just going to do that. Let's just avoid that entire problem. And then I need to read the first byte. Let's see. Read the first byte at the starting address, and then increment buffer. All right, so just keep reading bytes until we get to the end of the buffer. That should work, right? I think that'll work. If you have a link to a specific if you have a link to a specific $5 logic analyzer or whatever on eBay, I've looked at some of these things in the past and I haven't convinced myself to buy one yet. Although for this kind of thing, what do I need to handle? At most, like 2 megahertz, right? And at the minimum, it needs to be at least 400 kilohertz if I'm going to sniff the I2C or SPI bus, right? I think that's about right. If you have a link to a specific one or name, post it in the chat log here, and that would be totally awesome if it was something that I could fit like right here and just have the probes constantly here for these streams, and then you all could just watch the data. That would be so cool. Increment, iterator, and while loop. Oh, thank you. What do you think? Should I do it like this? I actually really don't like code that does that for several reasons. I just feel like it unnecessarily makes the code harder to read. I'm gonna go with this one. It's gonna compile to the same thing. It's pointless to even say, oh, it's more efficient or something like that. All right, you say do a for loop. Okay, let's see. What would that look like? Something like that, maybe? No, I'm not going to implement this recursively. I don't see any reason to implement it recursively. Really? That seems like you're asking for trouble here. Now, a lot of things tail recursion compilers are very good at optimizing, but it's not guaranteed by any means. So if I did a recursive loop here and I'm not in release build, this is going to be Stack Overflow. Bam. That will double write the first iterator position. It will double write the first iterator position. And you're saying a for loop here. Yeah. Okay. So the argument is go ahead and write a for loop for this bit and leave the top bit the same. All right. Why not? So no start condition or start, what is it called? Init expression. And then the condition is buffer not equal to end, and then the increment expression is that. Oh, let's see, I've got a message held for review. I can't actually see the message. I'm sorry. That's for the link for the logic analyzer. If you could just post that like description of it, that would be easiest because of YouTube's filtering and such. All right. Now, I'm ambivalent towards most of these things. I tend to write my algorithms as while loops personally. I feel like it's slightly more readable. Okay, so I can read a block of data, theoretically. Now I've got this I2C device base class here. And I want to use this to simplify add some no discard help here. Ooh, I wonder if we have enough C++ 20 help to do that. Logic Analyzer 8 channel. All right. Help if I actually saved the file. Yes, so the driver does have a block read. This device doesn't like the block read. So I'm doing the auto increment address read. And we'll get to, I have an idea here. Basically, let's see. Now, my theory, my plan here was to do it like this. Now, I don't want to quite implement the other thing yet, so. So now then, when I do this inheritance, I can pass this in and say, no, it does not support the read block data command, so it knows that it's going to use an auto increment instead. Theoretically slow, but I did a calculation on it. I mean, at 400 kilohertz, this device has exactly 64 bytes of RAM. It's not going to be slow on this device. I mean, it's not going to be problematically slow, I don't think. All right, so. Oh, I've actually, that is $700. I'm sure it's a great device, and I've actually, I know this company. But I'm not going to spend $700 on that for what we need for this video. So, yeah, why not? I'm at, I hope, hopefully no risk here of getting myself in trouble for accidental something coming up on my screen that it shouldn't. Okay, so these guys don't have their own screen or anything. That's what you're looking at. $7.59. Well, I guess I could pop over the current logic analyzer probe somewhere on the screen. That is really cheap. I was thinking of these like in the $100 range. Okay, I'll play with that idea. I see. I have seen the new Raspberry Pi Pico. I haven't spent a whole lot of time looking at it though. All right, so I think that this idea is going to work. This kind of gives me a configurable thing. And so I've got my buffer and my, so this ability right here where I'm doing this read byte over and over again thing to synchronize the buffer, I no longer have to do that. And I can, let's see, so this buffer needs to be, how many registers am I reading from this one? 1, 2, 3, 4, 5, 6. I'm reading 7 registers total here. I'm reading 7 registers, and if I do a sync, then I should just do read block, starting at address 0, and from the beginning to the end of this buffer. Now I'm just going to comment this out real quick, which I don't normally recommend commenting out code, but I need to see what it's doing. And then I can call the sync buffer. I had an idea for when I was going to call it. Sync time. Ah, right. Okay. So for those of you who weren't here for the last one of the things that we did is we actually get back a system clock time point for the current time. So I'm going to do the sync buffer here. So it'll sync the buffer, and then it'll read the seconds, minutes, hours, days, months, whatever, and that should work. Oh, we didn't. Let's see. Use of auto and parameter declaration only available with F concepts, but it's a warning. But you let me do it. I'm just going to leave it. I don't want to change to standard byte. Yeah, I see my parentheses are unbalanced comment just now. Too late. So I'm not using standard byte because standard byte is not an arithmetic type, and it would just add an extra level of pain for what I'm trying to do here. Oh, that's fun. So these time fields, time getting functions are const. And if I do a sync buffer, which is a non-const function, then I introduce a thread race problem for myself. That's kind of funny. I guess I'm going to just make the current time not const for the moment. I don't think we can do a structured binding here, Leslie, because I don't think the order of these values in the struct are guaranteed. I think that would be a potential problem for us. All right, I'm going to run this and see if it actually... it does seem to be reading the seconds correctly. And the hours at 1 hour, which is not right. This device has not been on for an hour. Oops. I'm gonna leave this run for a few more seconds. All right, something went wrong, didn't it? Hours, minutes, seconds. Sync the clock. Real-time clock. Okay, so I'm not actually doing my automatic sync at all. I'm only calling these hours, minutes, seconds functions, and I'm doing a sync buffer manually. And let's see, I'm gonna make sure. Well, that's reading 9 bytes. Zero, 1, 2, 3, 4, 5, 6. Huh. No, that should be 7 bytes. All of the different mechanisms that I have for trying to get this working. Is there any reason to use direct list init when declaring and initializing a variable via return value of a function call in one line? I'm not entirely sure what the question is. If it's related to a specific line of code and what I've been working on right now. Okay, that's working. And my stupid read block function isn't working. The seconds appeared to be working, but not anything after that. And the seconds would be the first byte. Read byte, passing the starting address. Increment the begin pointer. While the buffer, the begin does not equal the end. Increment the begin address. Assign the value to the next byte read. Read byte. I2C SMBus read byte. So I read this before. If I just use the file handle directly and ask it to read 1 byte, that should be the equivalent of calling this function. I verified this before I bothered any of you all with trying to do this. And it's just not working. This is very annoying. First byte received and handled. Let's see. If the register pointer is not written to before the initiation of a read mode, the first address that is read is the last one stored in the register pointer. The register pointer automatically increments after each byte read. It really should be doing what I expect it to be doing, shouldn't it? I am so confused. I feel like this just keeps happening. It's not working like it should be. I'm going to double check this. Using I2C read equivalent to reading a single byte from the file. Then that's exactly what I'm trying to do. This should be the I2C read a single byte. Always best to see what's really happening on the wire. Is the pointer in the correct place before it is read? It should be, because I set up the read byte with the starting address, and that read block function passing a starting address with the current handle, and I'm saying from 0, read from 0. So the first time read through, it's writing the address. Wrong one. First time through, it writes the starting address and the device to the wire. So that's the register, 0. And then each subsequent time through, I swear I am following the actual documentation here. Wrong website, or wrong page. I have multiple versions of read block here. I've got what I'm looking at here is the member function version of read block. So I'm passing in 0, which takes its own device ID that it's got. Or not device ID, but yeah, it's device handle here thing. So that's the member function versus the free function version of it. So this one is the member function calling the free function version. And this is the member function calling its base class. It's calling its base class member function version. Sure, all right. I can't even find the right version. All right. Oh. Watch it be funny that it's actually a compiler bug due to this F concepts nonsense from an old version of GCC. But I think we have enough debug info in here to actually try to get an idea as to... Oh, did I switch it over so I'm calling the correct one? I did. Okay, good. Well, that's a terrible link. All right. Oops. I2C git command to test. I should try that. That's a good point. I'll try that in a moment. Let's get to the actual speed log documents. I haven't spent enough time with it recently. Set level. Oh, it looks like I did that right. All right, so trace will dump all of the things. Those really should be trace messages probably anyhow. It's reading data from somewhere, isn't it? Yeah. But it's clearly doing something. It's clearly doing something, isn't it? What in the world is it doing? All right, so I2C get. This is device 68. Bus 1, device. Can I just put 68? We'll accept that. Okay, yeah. And I want to get a byte? Sure. Add address 0. No. Oh, I have that backward. All right, 48 is what it says is that address 1. And then 0 at address 2. And 1 at address 3. Yeah, clearly it's not a GCC or a Clang problem, and I looked at upgrading Clang though, and do me any good either as far as what is available on Raspbian here. And it shouldn't be an Indianness problem because it's just reading 1 byte at a time theoretically. It kind of feels like it's just reading every other byte. Yeah, I can read 2 bytes at a time using the, so I want to get back to this comment here. Perhaps I squared CS and bus read byte make one transaction with a start and a stop. Thinking about that, yes, it does. Info about register pointer and datasheet is about read after write mode. I'm putting it in read mode. Okay, so this is saying if I were to write a single byte of the starting address and no further data, and then read, which actually falls in line with some of the other stuff that I've looked at in these docs. So write quick versus write byte, they both just have a value. Thanks for the documentation. All right, I'm going to attempt what is based on what Andre is saying. I'm telling you, the read block function totally did not work when I last tried it. It just gave an error every time. That's why we're going down this road, but I will give it another shot in a moment here. But I want to try this question of writing the address and then reading and see what happens. Oops. So if this is correct, then I just want to do a write byte, I2C, SM bus, whatever. I want to write a byte that is just the address to this device. And then I want to read until I've reached the end. I want to try this because I spent too much time reading docs and I don't know. Yeah, this is definitely how the documents for the EEPROM device say to work. No question, this is how the EEPROM device that we haven't yet tried touching says you have to write the address and then read. And it has an auto increment register as well. But I don't know, we'll try it, right? It's reading back the exact same thing. It is no difference at all than what I had done a moment ago. I did compile it, right? Maybe I didn't. I don't know. Oh yeah, no, it does say next byte read, next byte read, next byte read. It doesn't, The function for read byte might end the transaction. Yeah. I guess it's, yeah. That must be what it's doing, I guess. But then it doesn't seem that it seems that if I'm going to use the I2C interface, that I don't have a choice here then at that point. Oh, hello. Do a combined read-write transaction without stop in between. Only valid if the adapter has I2C func I2C, the argument. Pointer to an array of simple messages, number of messages to exchange. Huh. Yeah. It does look like this is what I would have to do. Is use a direct IO control without passing a stop in between. Now, theoretically, process call. Theoretically, that's what the read block is supposed to do. And I know you all keep telling me to do the read block data. And I will give it another try. That's what this is read block data. And it passes in a pointer to 32 bytes of data because it can read up to 32 bytes of data. And then it returns, this function should work. It returns the result code, which is the number of bytes read, followed by the actual data read. And I'm just going to go ahead and give that another try, and we'll see what happens. Where do I want to do this? This code's going to end up all out of whack here. With the read block function, I send the device address, the register that I want to read from, and then the array of data. So that's 3 arguments, and that is what it is telling me to do here. This is the generic command thing. And of course, there is no documentation on it. I actually, after the last stream, went and I just started reading the source code for these things. Whatever the byte would be interpreted by the slave device, byte array into which data will be read, big enough to hold the data returned by the slave. SMBus allows at most 32 bytes. Executes SMBus block read protocol returning negative. Let's see. Oh, wrong one. Oh no, this is the right one. Nope. Yeah. All right. I'm agreeing with everyone here. This needs to be single transaction. That's where things are getting messed up. It's like it's just dropping the last byte on the floor. Now, all right, I'm going to go ahead and do it this way. I'm sure not the best option, but all right, so with this one, I'm reading the result, and then I'm not yet saving this result into the begin and end iterators. How do I want to do this? Yeah, all right, let's see what happens. So this one will read and then just return whether it might be a knack or something like you said, if it says that it doesn't have this much data. Excuse me. This is all taking far longer than it should. I'm just trying to remember if there's a copy that has in begin, in end, out begin. Really? There's no one that has an out end also? Whatever. All right, so I'm going to read this in. I'm going to copy it to that buffer. I'll say again, no, this code's not ideal. I'm just trying to get it working. Oh, that's right. I don't need to create this thing and pass it in. Theoretically, this is fun, right? Oh, that's bad. That's going to overwrite my buffer. Standard expected doesn't exist. Standard expected was proposed for C++20. It was never accepted. It's not in any standard library. Maybe we'll get it in C++26. We'll see. Oh, it's not calling my different function here because I didn't say true it supports bulk read. I am zero initializing it. I'm not relying on here. This is absolutely guaranteed to zero initialize the buffer when I'm initializing it with the empty braces. I don't need to write the code to do that. The compiler definitely will write it for me. But I am not initializing this buffer. Yeah, and I'm gonna write over my buffer here. But I'm not gonna worry about that at the moment. Watch, I mean, I'm sure it'll work this time, right? Because it wasn't working when I last did the stream. It'll work today. So it'll just make it look like I've been, doing something crazy this whole last hour and a half. Error, reading block of data from 0. Error result, -71. All right. You can check error no to see what went wrong. All right. I cannot remember how to get an actual string description of what error no had in it. There is a string description in here somewhere, right? Someone already tell me? No. Error, str error. str error returns a string. All right, fine. That's in this function. Yeah, I could use PR. I'm not sure what to tell you about only being able to see 144p. Sorry, I don't really have control over YouTube's thing here. So what was my error description? str error, error no. Oops, misbalanced parentheses again. On some ancient systems, I'll just leave you with this message here. Excuse me, when I tell that to compile. Error no.h was not present or did not declare error no, so it was necessary to declare error no manually. Yeah, that sounds like a bad plan. Protocol error. All right, this device does not support whatever this is trying to do with this protocol. That's what we know. It's ridiculous. All right, I'm gonna go back to this because this device clearly doesn't support read block data. All right, clearly doesn't support that. So And so we know it doesn't support the read block data SM bus protocol. So that's our first problem. Our second problem is that I need to do this IO control multi-transactional read if I want to do this correctly. I think. Now, rebooting is not going to solve my problem because, yeah, the device is still doing what it needs to be doing. I can read back the bytes just fine using other mechanisms. I know that I'm fairly confident about this because we did this before. I rebooted several times before and it didn't gain us anything. Okay. So this read block. I have an idea. only want to spend so much time hacking on this, honestly. Oh, that is terrible. What is it doing? Oh, stop that. Hey. Actually, I guess I don't need that. There. Uh, 1:59 instead of 1 o'clock, or if it's exactly at midnight on December 31st, but it will be actually important for other devices. So I'm just trying to abstract it away a little bit. I do want to support these protocols in the future, Yes, and sorry, you're answering Katana's question. Yeah, selecting the current register. That's why the right was there. All right. I think this is all just wrong at the moment. Whatever. Make that a trace command. No, clearly, yeah, none of this is working correctly, and it's probably not even right for most of these things. All right. I do not have a random oscilloscope lying around. Sorry. I've never owned an oscilloscope. I've had them on my desk at work long time ago, and as you can probably tell from watching me do this, it's been a long time since I've done this kind of thing. All right, so I think I have accomplished my primary goal today, which was to give a single interface for reading and writing blocks of data. That was really my primary goal. So I can sync this buffer from the device into my local buffer and then be able to output this. And I think this is all correct, except now I need to use my block read mode of 1 byte at a time. And now we can continue to build on this, right? So as I support more devices, maybe I'll be able to get other types of block read modes working. And let's see, the SMBus protocol, I2C. Okay, yeah, this one is not actually implemented. That's bad, but we're getting closer. Ooh, I have an idea. So I can correctly specify what the device is supposed to be able to do. And I have a consistent interface, I hope. So yeah, I got a fall through warning there. That doesn't surprise me because I just fixed that. Yeah, I know. See, you don't understand. I'm having fun, right? Actually, there's only 80 people viewing now. Huh. All right. Jump to case label required from here. Warning. Warning. What am I doing wrong? Right. Fine. There. Right. I can't have a... All right. It's probably bad, but I've actually moved away from using case statements and opted for a standard array approach to multiple choices taking a lambda. So you have an array of lambdas. Well, you have to give them function pointer types, right? Whoa. That's not quite right now, is it? All right, read block from address 0, beginning of the end of this. Let's just make it an 8-byte buffer, sure. Pretty sure I'm only using 7 of those bytes. Read block 1 byte at a time. Knew I made my for loop overly complicated. I don't know. I mean, you know, use cases for both of those things work. If you wanted to build this whole thing at const per time or whatever, I mean, I think a switch statement is okay here, personally. I feel like having function pointers would be overly complicated. And in this case, by the way, the switch statement, this read mode, this is a compile time switch. So for anyone who's curious about like efficiency or anything here, this switch case will go away at compile time. There's no question, because read mode was specified as a compile time template parameter. Ah, okay. That looks better. Now this hello, by the way, that I'm reading out down here, if you didn't know this before, I have this read object and write object. So I can give it a data location. I can say at address, at position 0, this thing, this device has, what is it? 56 bytes of RAM that we can just use for anything we want to. And so at position 0, I'm writing in this array of HELLO, and then I am reading back this object as a C++ array. So I've got this type safe read and write data thing into here. And this is actually what inspired me to do the rest of this nonsense, because I want to not have to re-implement this read and write code once I have a more efficient way of doing this at some point in the future. Oh, the solution that I have is that I just went back to reading 1 byte at a time, Jack. That's all I'm doing right now, is I'm reading 1 byte at a time until at someday I decide to try to fix the rest of this with this ioctl call. I think this is, I think this is going to be perhaps my next stream would be doing this as a series of ioctl reads, something like that. Yeah, okay. So you didn't miss a whole lot. So what I want to do is I want to clean up this read data, read object and write object, and then I want to end this stream because I've been on long enough and it's almost good enough weather to take the dog on a walk. All right, so for the read object, I'm creating a data object. I could theoretically now, the way that I'm cleaning this up, be able to use bitcast in the future, but what I am doing is not undefined behavior because I have a static assert saying that this thing is trivial and that its offset, read and write offset, plus its size is less than the allowed 56 bytes in this object here. So I have a pointer to the data that I want to read into and a starting address because this is the 9th byte in the RAM on the RTC that I can read and write into. And so I should be able to do a read block starting at start and from begin to size of data type. I think that's right. My ultimate goal, I think, like I said, I don't really have a real goal, but theoretically, my ultimate goal is that we'll have some sort of C++ 20-ish thing that's lightweight and reusable, and we can template on, whatever types of devices you want to use. So I have in here this I2C device and this generic read byte, write byte. Now, what I want to do is take these functions and make them some sort of dependency injection or something like that, so that if you're on a device that has these I/O controls and you're on a full Linux device, then you would just be able to plug this in. If you are on a lighter weight device, then you would plug something else in and you would still be able to use this stuff. Okay, so I'm now getting this multi-write, and as starting, I'm reading 5 bytes. That's correct, HELLO, from device 3, starting at address 8, and that's correct. And so let's do this write object one. Now, I see the comment that is not being shown because of the cussing that was used in it. It was automatically hidden by YouTube. At some point, I'm going to need to jump into the disassembly on this stuff. I know you say you think that this is overly complicated, but a lot of what the point of what I'm doing is that a considerable portion of this just goes away at compile time. Template choices and dependency injection options, that kind of thing, make it effectively zero cost abstractions for runtime. And yeah, it's maybe a little bit overly complicated in some cases, but the interface that you get is what I'm aiming for. Forget the implementation and let's look at the interface. I can say, create a real-time clock device and then get me back the current time, get me back the current hours. And I can get this super high-level interface that at compile time is going to be very lightweight. And that's ultimately what we want for our embedded devices, right? All right. Oh, yeah. Sorry. I did think that I said that I was going to go, but here I'm not going. So let's get that working. Can't even remember my own terminology. It's going to be the same exact code, just no, I have not spent any real time on a functional programming language. I tried to, university. I did not do well. I need to spend more time with Lisp. I feel like I missed something here. Compiler, let me know. Oops. It's less about execution efficiency and more about binary size, which I believe is important on very small devices. Oh yeah, no. Format is definitely going to have to come out of the implementation details of this stuff. No question. The format speed log, no way. That's not going to happen on an embedded device. Good old holdover from C there. I have to, can't use the function before it's declared. Come on, what's your problem? Yeah, absolutely no question. I squared, the formatting and speed log that I'm using is definitely not gonna fly on an embedded device. That's gonna have to be pulled out. I just want to make sure that I'm not rereading the same data that's been in here for a week. And I should not get a fall through warning anymore, right? Okay, good, I won't. I guess I'm gonna have to enable -f concepts at some point. All right, if this runs and we read Jello back, then I'm gonna save this work and I'm gonna hang it up for today. But this was fun, and thanks everyone for joining me. If it doesn't work, then I'll still be on for a few more minutes. All right, red back Jello. Okay, so at least I do have some things here, and I'll be able to keep speed log in the higher level, the I2C ones, and then remove it, or excuse me, from the /dev/I2C implementation, and then we'll be able to make, hopefully, I didn't get nearly as far as I wanted to, but something a little bit more reusable for the future here. But I think I've got enough pieces in place that it should be super fast to start to implement, hopefully, maybe the EEPROM read and write, or maybe we'll start doing more work with the OLED device here. But I'm going to have to figure out how to get those block reads and block writes a little bit faster, particularly when we get to the OLED device. So anyhow, yeah, thanks for joining me. This was fun. Yeah, Jello world. All right, cool. All right, I'll catch y'all later. Thanks for coming on.